False cause. So the false cause, also known as correlation isn't causation, which is a little more descriptive, is actually perhaps one of the most common fallacies, in my opinion, maybe more common than the ad hominem. I see this cropping up again and again and again, people failing to realize that just because two things are correlated or related in time in some way doesn't necessarily mean one thing causes the other. Right? So just to take a simple, obvious example, every time, let's say you have a daughter, every time your daughter brushes her teeth at night, her hair is growing longer, right? It's just, her hair is growing, people's hair grows. But it doesn't mean when she's brushing her teeth, it's causing her hair to grow. They're just happening at the same time. Every time I wake up in the morning, the sun is sort of rising as I'm starting my car. That doesn't mean that one is related to the other. That either the sun rising is causing my car to start, or vice versa. So there's lots of stuff that happens in the world, but whether something causes something else is a much more complicated process. And when I talk about this fallacy in my face-to-face class, I actually have my students reflect on how is a cause discovered in science. And it's usually pretty interesting because there's so many different answers, and we all realize at the end that it ain't easy to figure out a cause, right? So even just to figure out, one basic scientific law, if it's caused every time, if the same effect is resulting from the cause, we have to do multiple repeatable experiments over and over to verify that connection. So it's not easy to figure out causes. The reason this is a fallacy is that the speaker pretends it's easy. They say, oh, these two things are kind of correlated, well, they're probably caused. Totally different things to say something's correlated versus something's caused. You can even see this in your own experience. Have you ever eaten something that you felt sick the next day and you weren't sure what you ate that made you sick? You can often figure it out by eliminating what you normally eat. Right? You can say, well, I always eat pizza, and I ate pizza yesterday. That didn't cause the problem. And you start thinking about what you ate, and then you're like, well, I had this burrito that had this particular type, let's just say cod fish in it or something. You're like, I don't usually have cod fish, so maybe that was what caused me to get sick. And let's say you don't think about it, and then another time you just kind of by accident, you have some cod, you're at a dinner and you have some cod fish, and you get sick again. And now you can say, wait a minute, in both of those cases, cod, I was sick and cod was related to it. So in other words, in both cases, cod was correlated with your sickness. But it was only on the second time that you started to think, maybe there's a causal relation here. So that just shows you that it takes time before you can even determine if there's a relationship beyond correlation between two things or two events. So we can fail to appreciate causation in this way in a number of dimensions, and that's what those variations are. Sometimes we may just be overlooking a coincidence, right? Two things are just happen to be related, like the girl's hair growing and the brushing of the teeth. There are other times where we're actually looking later in the causal process, but really there was a common cause that led to both of them. So for instance, let me give you an example of that last one. A common cause. Chimney fires and long underwear purges increase in frequency at the very same time. Therefore, chimney fires cause people to buy long underwear. So in other words, people are lighting fires in their fireplace, and people are buying long underwear at the same time. They're correlated. So chimney fires are causing the purchases of long underwear. Or there's a common cause beneath both of those, which is cold weather. Maybe it's cold weather that's leading to the people to light chimney fires and buy warmer clothes. Right? So there's other cases where we can misinterpret the causal process to begin with. Another very common one is the regression to the mean. So here's the problem. So look at that. Let's start with that chart. Everybody, when they perform at any game or any activity, we can tally up statistics of their performance, right? We can see how often they do this, how often they do that. And obviously people have been doing that with sports for many years. So there's a tally of how many points LeBron James makes and his averages and so forth. And over time, these averages emerge. And we see that roughly speaking, LeBron James is on this trajectory, but sometimes he does better and sometimes he does worse. He has bad games, he has good games. But in the end, there will be a mean pattern that emerges over time. And anybody who studies statistics and is looking at the statistics of a sports team or organization will see these means and differences. In fact, to some extent, this is what the movie Moneyball was about, if anyone's seen that. But the point is there's a mean. Now, what we often forget is that when somebody does poorly or does well, they're eventually going to revert back to their mean performance at some point. They're going to have good games, they're going to have bad games, but ultimately it's going to come to over time, it's going to come to some mean performance. Where regression from the mean gets its name is that we fail to appreciate that it regresses to the mean, and we assume there was some cause there. So, for instance, now I know this example doesn't relate to LeBron, so just take that in mind. In this example on the PowerPoint at the top there, it says the girls were well below their average on Monday, so I made them do 50 sets of push-ups. Guess what? Their average was much better on Tuesday. Push-ups did the trick. So this coach in this case, in this example, fails to appreciate regression to the mean because he assumes that it's him having them do their push-ups that led them back to do better. But they had already been at a low point. So they were gonna just statistically regress to the mean and come back up to a higher point no matter what. So the push-ups probably didn't have any effect at all. So this coach failed to appreciate that regression to the mean. So it often happens in the case of sports that we fail to appreciate that. But that's just one of the many ways that we can fail to understand causality. The bottom line is, just because two things are correlated in time, doesn't mean they're causally related. It doesn't mean one causes the other.